Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Faisal Nidal bin myself. My metric number is 2213867. So today I'll be explaining and sort of demo the code for the model ResNet 50 and also ResNet. So due to time constraint and how long it takes to actually run both models, so I'll be explaining it through PDF, and also that includes the output. So right here, after loading the dataset, I need to prepare the data or the images. I need to rescale, and I need to rotate it. I need to rescale it and everything so that it fits the requirement of ResNet 50 model. So after wrangling the data, I need to create the model. So basically, the difference between all the model on how to actually define the model is from this line, the base model. So right here, for ResNet 50, I write ResNet 50. For ResNet 101, 101, and so forth. So right here, the base model tradable, this one is for fine tuning. So when we fine tune, we will get a better result. So right here, we also do early stopping and such. Then we compile the model after a few epochs. So this is when it's true. Then when the base model dot trainable is true, then we actually fine tune it. If it's false, then we do not fine tune it. So that's the difference between these two codes. So by fine tuning, it means that we unfreeze the layers, unfreeze a few layers, and then after a few iterations, it will stop and then freeze the layer back. So that's basically it. So and then we do the learning rate, and after a few epochs, we'll stop, and then it's time for the model to be evaluated. So here we can see that this is the coefficient matrix, and the accuracy is around 86%. So this is the ROC, and also we actually compare the result between fine tuning and not fine tuning. So as you can see here, this blue line is the training accuracy before we fine tune the model, and the green one is after we fine tune the model. So this fine tuning actually helps to improve the result. So that is for the ResNet 50. So for the ResNet, it's a bit more complicated because ResNet uses torch. So there's a lot of loading of data and also from other sources, from third-party sources, to actually run this code. So please bear with me. So actually, the concept is the same as the other model. It's just that the syntax is a little bit different. So for this part, of course, we actually resize the data, and then resize the images, and then we train it. So after a few train for 10 epochs, and then we get to the evaluation. So as you can see here, the accuracy is quite high. A little bit the same with the ResNet 50, which is 85%. And then this is the confusion matrix, which indicates a good result. So that is all for the demo for ResNet 50 and ResNet. Thank you very much.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Wizuddin bin Ahmad Rizwan, and my matrix number is 2211679. Now I'm going to demo for the ResNet 101. Actually, we are using the same setup from the ResNet 50. We use the same tune, the same learning rate, also, and the same density. We have 128 layer, and also everything the same. The architecture is also the same. So, and after we run the model, actually, in the classification report, that we found that the accuracy for this ResNet 101 is worse than ResNet 50. And if you see in the receiver operating characteristic ROC curve, the area under curve is actually 0.89. For your information, in ResNet 50, our ResNet 50, our AUC is 0.94, and the accuracy for ResNet 50 is 0.86. So ResNet 101 is not suitable for this image classification. And also, if you can see to the comparison of training and validation accuracy, and for the initial and validation accuracy is it has the low score between 0.5 and 0.8. But after fine tune, we got in train accuracy is very high, and also the validation accuracy is also high. I think that's it for ResNet 101.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Daniel bin Muzadi, and I'll be explaining about the ResNet 152, which is part of the ResNet family that has 152 layer deep network. So our dataset consists of chest X-ray images that is split into three, which is training, validation and test sets. The structured directories make it easy to load and manage the data. So firstly, we pre-process the images by rescaling the pixel values to the range of 0, 1 and resizing them to 224 times 224 pixels to match ResNet 152 input dimensions. On the training side, we apply transformations such as random rotation, shifting, zooming and horizontal flipping. So we use the pre-trained ResNet 152 model leveraging weights from ImageNet to build on its learned features. The top layers of the pre-trained model are replaced with a global average pooling layer, a dense layer with 128 neurons and ReLU activation, a sigmoid output layer for binary classification. So this approach reduces the computational cost and the training time, make it deep learning accessible even for smaller dataset. So we initially phrase the ResNet 152 layers to retain their pre-trained features while training the added layers. So the model is compiled using the Adam optimizer for adaptive learning rates, binary cost entropy as the loss function, and accuracy as the primary evaluation metric. So early stopping monitors validation accuracy and halts training if there's no improvement for 5 epochs, saving time and preventing overfitting. After training the added layers, we unfreeze the top layers of ResNet 152 for fine-tuning. This allows the model to adapt high-level features to our dataset. The fine-tuning step is particularly effective for adapting deep models like ResNet 152 to specific domains. So to evaluate the performance, we use metrics like accuracy, confusion matrix and ROC curve. As you can see here, this is the confusion matrix, the ROC curve. So the confusion matrix reveals how well the model distinguishes between two classes, while the ROC curve and the AUC score measures its ability to separate them. To further enhance the model, we use Bayesian optimization to fine-tune the hyperparameter of a gradient boosting machine, which is GBM. So this systematic approach balances the exploration and exploitation to identify optimal settings such as the max dip, the learning rate, number of estimators and subsample rate. So the hyperparameter tuning helps us maximize the model's performance while avoiding overfitting or underfitting. ResNet 152 has proven effective in tasks like medical imaging, autonomous driving, and any scenario where extracting detailed image features is crucial. So in our case, it excels at distinguishing between normal and disease chest X-rays, a task crucial for healthcare diagnostics. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Daniel, and today I'm going to present about using ResNet 50 model for pneumonia detection system. So in this code, this is the code for using model ResNet 50 for our pneumonia prediction, and our data has the train, test and validation dataset. In this dataset, there is 5,260 images belongs to the train file, and 60 images belong to the validation file, and test has 624 images. The two classes is normal classes and pneumonia class. So this is the the coding for building the ResNet 50 model, and we use Adam as the optimizer. And this is the training code. We also fine-tune the model to unfreeze the layers and freeze the layers for stability. And next, for the evaluation, we have the classification report and confusion matrix. This is the classification report. The classification reports we get, the accuracy for this model is 0.7, which is 87%. And this is the confusion matrix. We also did ROC curve and IUC. This is the ROC curve. We get the IUC score is 0.96, which is 96%. And this is the comparison of training and validation accuracy. For the green line, we get the train accuracy, which is fine-tuned. The blue line is the train accuracy, which is the initial. And the yellow line is the validation accuracy, and the last one, red one, is the validation accuracy, which is fine-tuned. Okay, that's all for the ResNet 50 model. Okay, next I'm going to present about our deployment for our model. For this deployment, we use Streamlit as our interface, and we use the model ResNet 50 because it is the most stable model out of our 5 model. ResNet 101, ResNet 152, ResNext, and ResNest. Okay, this is just for the title, is chest ray extract pneumonia detection, and we also write the upload chest image to classify is normal or pneumonia. And for the code, that the upload file is the command for if we want to upload any images of the chest X-ray. Okay, and then we have the display upload the image. We also process the image and to make prediction. This code is the prediction and the learning process is based on our ResNet model code. So after we run the code, it will display. Okay, this is the main page. We have the title and message that upload the chest ray image, normal and choose X-ray image. In this page, we can drag or drop any file. If you have the file in your in the document, you can upload it. And if you want to drag the file from Google, also can. And if we upload the image, it will come like this. This is the X-ray image that we get from the Google, and it will give the output of the prediction, which is pneumonia, and the confidence is 84%. Okay, that's all for the deployment.